Welcome to Ms. Taylor's geometry class. So today we're going to talk about measuring segments, and we're going to do that 3 different ways. We're going to do measuring segments on a number line. We're going to do measuring segments when we're not given a number line and given algebraic equations. And then finally, we're going to measure segments on a graph. So first, we're going to talk about this ruler postulate. Postulates and theorems are kind of our rules of geometry. They tell us, they give us definitions, they tell us what things do, and they're kind of what we use to think through and solve problems. So our ruler postulate just says that points on a line, especially a number line, match real numbers, and those real numbers respond to coordinates of the point. So basically, a number line is our basic numbers, and it's how we count, and that's all we really need to know. The other thing the ruler postulate helps us with is it helps us understand that we can measure the distance of line segments on a number line. So our distance is the absolute value of the difference between our 2 coordinates. So we end up getting a formula that looks like this. So absolute value are these 2 straight lines right here. And absolute value just means that anything inside those lines becomes positive, because distance is, and I'm going to do this in all caps, always, let's spell that right, positive. You can't go running backwards. You can't drive, or you can run backwards, but you can't run negative miles, negative 100s. You can't drive negative distance. Our distance, we always measure it in positives. So if we're given line segment AB, let me move this. A is going to be x1, B is going to be x2. So I'm going to find B on my number line and write -2. My equation tells me to write minus, and then I'm going to write A, my x1, -4. I'm going to put them in our absolute value markers. A negative becomes a positive, so -2 plus 4 is going to be what the problem becomes, and then a -2 plus 4 equals 2. And then anything inside our absolute value becomes positive, so our answer is 2. So now we're going to do the same thing with CB. C would be my x1, B would be my x2. So x2 goes first, so we're going to go -2 minus, and then we're going to go C, which is my x1, 1. So -2 minus 1 becomes a -3. And again, we use our absolute value markers. And because we used our absolute value markers, everything inside becomes positive. So my answer is 3. I want you to try AD on your own and check your answers with the completed notes. All right, so the next thing that we need to understand is our segment addition postulate. This is a postulate that we're going to use all year long. And what our postulate tells us is that if point B on our line segment is in between A and C, then the part that is AB plus the part that is BC equals the whole line, which is AC. So when we think about segment addition postulate, we think about part plus part equals whole. Part plus part equals whole. And so that's how we're going to think about that, and that's how we're going to solve these. So PQ equals 9, and QR equals 28. So again, our segment addition postulate tells us that part plus part equals the whole thing. So 9 plus 28 is going to be 37. So line segment PR is going to equal 37 because part plus part equals whole. So now let's look at the second half of our problem. QR equals 17. PR equals 21, so that's going to be the whole thing. And we need to find PQ. So I'm going to put an X for PQ. So X plus 17 equals 21. So we have an equation. We can subtract 17 from both sides, and X is going to equal 4. And so then line segment PQ equals 4. And so this is just kind of a, we just got to keep telling ourselves part plus part equals whole. So now let's look at it when we have algebra involved. So SK is 4x minus 15. That's a minus sign. KY is 2x plus 9. That's a 9, not a 4. And then finally, sy is 36 minus x. So again, part plus part equals whole. So our first step is going to be to combine our like terms on the same side of the equal sign. So 4 plus 2 is 6x. Negative 15 plus 9 should be a negative 6. And then we bring down our 36 minus x. I am going to add my x to the other side, add my x to the other side. 7x minus 6 equals 36 because those x's cancel. My next step is going to be add 6 to both sides. So we get 7x equals 42. And then our last and final step is divide by 7. So x is going to equal 6. So we're going to put a 6 right there because we know that's what x stands for. But now the question's asking for what is sk equals. So I need to find sk, which is 4x minus 15. And I need to sub in 6 for my x. So 4 times 6 is 24 minus 15, which should be 9. So sk equals 9. I'm going to do the same thing with ky. 2x plus 9 equals ky. So 2 times 6 plus 9. So 12 plus 9 should be 21 equals ky. I said 21, yep. And then finally, 36 minus x. So 36 minus 6 should get me 30. And I can check my answer by doing part plus part. So 9 plus 21 is 30, and 30 is the same as my whole. All right, so one real quick thing. So if I look at these two segments right here, A and B, and I measure the distance, 3 minus a negative 1 is 4. Negative 1 plus 5 is also going to be 4. So when we talk about congruent segments, we're talking about segments that are the same or segments that are equal. So if we look at the picture to the right, if line segment AB is equal to line segment CD, then our segments are congruent. So once we know they are congruent, we do not use our equal sign, we write them differently. We write down line segment AB is congruent to line segment CD. So our congruent sign is an equal sign with that tilde on top. So now we're going to talk about distance formula and how we find distance in 2 dimensions on a graph. So our distance formula is distance equals, and then we're going to have a really big square root. So we're going to go parentheses x2 minus x1 parentheses squared plus y2 minus y1 squared. We are always going to write our answers as simplified radicals when we use distance formula. So let's look at our first example. So we're going to find this point, which is 0, 7. That's going to be my x1, my y1. And then our other point is going to be 4, 1, which is x2, y2. So now we need to plug these values into our distance formula. So we need our big square root. Our x2 is 4 minus our x1 is 0, then we square, plus y2 is 1 minus 7 squared. So now we need to do what's inside our parentheses. So 4 minus 0 is 4, and so we're going to square the 4. 1 minus 7 is going to be a negative 6, and so we need to square that, and now I'm going to put the square root on top. So one quick thing. Distance is always positive, and distance is always going to be positive because, a negative 6 squared is the same thing as negative 6 times negative 6, which is always going to become a positive answer. So 4 squared is going to be 16. Negative 6 squared is going to be 36. 36 plus 16. 6 and 6 is 8. 3, 4. Carry the 158. Sorry, my brain stopped working for a second. And now we need to find the square. We need to simplify our square root. So I know that 58 can be divided by 4. It becomes 1. No, it's a 2. It should be a 52. My brain can't add this morning. And then it goes into 12 3 times. So we rewrite it as the square root of 4 and the square root of 13. Since 4 is a perfect square, we're going to take the perfect square of 4. It becomes 2. 13 is not a perfect square, and so that is our final answer. I want to show you one other thing about the distance formula that we know, and kind of show you how we came about it and why it exists. We are going to turn these 2 dots into a right triangle. And so if we turn them in a right triangle, we're going to find the distance between them, or the distance of the sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that distance is 12. 1, 2, 3, 4, 5, 6, 7, 8. That distance is 9. So now we have Pythagorean theorem. We have a squared plus b squared equals c squared. So my a squared is 12, my b squared is 9, and I'm looking for c squared. So 12 squared gets me 144, 9 squared is 81, and then we have c squared. So we get a 5 when we add it together, 12, carry the 1, so 225 is c squared. And the way that we get rid of a square is we take the square root. So the square root of 225 is 15. So this side right here is 15. So our distance formula is just Pythagorean theorem reorganized. And so if you have a graph, you can use Pythagorean theorem to find your distance. If you don't have a graph, you're going to have to use your distance formula. I want you to try this one on your own and check your answer with the completed notes.